For blood test number 2 in 2025, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 29.8 years, which is 22 years younger than my chronological. Now note that this biological age calculator includes 9 biomarkers that are representative of many organ systems, but it may have blind spots. And with that in mind, I'm measuring a whole bunch of other stuff. So in today's video, we'll take a look at the full lab test report and we'll identify strengths and weaknesses. So starting off with page 1, and note that these blood tests and all of the blood tests that are in this video, I don't go to my doctor to order them or basically plead with them to order them. I go to altalabtests.com where I pick exactly the test that I want. I then bring that to Quest Diagnostics, pay the blood draw fee, which is less than $10, and then I get the majority of these results next day or within a few days. So if you're into blood testing like me and you want to help support the channel, there's an affiliate link in the video's description. All right, so let's start off at the top, starting with HDL, which was 67 milligrams per deciliter. Now, generally, most people think that higher is better for HDL. And with that in mind, my HDL has now been greater than or equal to 50 milligrams per deciliter for 15 tests in a row. And HDL average over the HDL average over those 15 tests is 57 milligrams per deciliter. Now that's good news because the optimal range for HDL, and that's based on a meta-analysis of 3.4 million people, is 50 to 60, at least in men. It's a slightly wider range in women. The optimal range is 50 to 60 milligrams per deciliter. So with that in mind, I've coded my HDL as red as it's a bit too high. Now you could say, all right, the risk increase for 67 versus 60, maybe it's not that great, but it's data that's moving in the wrong direction. And I'll have more on the HDL story as it potentially links with lymphocytes a bit later in the video. All right, next up are triglycerides. So although my 66 milligrams per deciliter isn't terribly high, there is published data that less than 45 is associated with lowest risk of death from coronary heart disease. And heart disease runs in my family, so less than 45 is my current target, so I've got a little bit of work to do as they're currently 66. Now note that if I focused on the reference range for these and other biomarkers, as I'll go into in depth in this video, I would be misleading myself into thinking that I'm completely fine just based on the reference range. For example, the lab's reference range for HDL is just greater than 40 with no upper limit. And for triglycerides, it's anything less than 150. So note that the reference range is not the optimal range. And I know that because I have a tier specifically designed for what's optimal for biomarkers on Patreon. This tier currently includes more than 2 hours of content, data from 45 published papers for how each of these 29 biomarkers changes during aging and how they associate with risk of death for all causes. So if you're interested in what may be optimal for health and longevity, rather than focusing on the reference range, this may be the tier for you. It also includes what's optimal for those lipoproteins, HDL, LDL, and triglycerides. As now we'll take a look at my LDL. So for this test, it was 79 milligrams per deciliter, which is in the optimal range, 65 to 120. And again, that's based on lowest coronary heart disease mortality risk. Now, there are some epidemiological papers that show higher LDL is optimal. I covered that in depth in the Patreon video, and I may include that in a future YouTube video with a bit more to the story of how reverse causation is likely driving the lower HDL is worse effect. But that's a story for another day. On to HSCRP, which was, again, less than 0.2 milligrams per liter. Note that it's now 23 tests in a row where HSCRP has been the detection limit from the lab. The detection limit for Quest Lab used to be less than 0.3 milligrams per liter. So it's been 23 tests where I've been below that. But for the past 6 tests in a row, for whatever reason, Quest's lower limit is now 0.2 milligrams per liter, and I've been at exactly that for 6 tests in a row. So good news for HSCRP. And then a weak spot, homocysteine, 11.1. If we go by the reference range, I'm good, but I've had values that were close to half of this about 20 years ago, so this is not a genetic effect. And for those who are into measuring homocysteine that are right now screaming, take TMG. I've experimented with high-dose TMG in the past. 4 grams per day didn't make a dent. What may make a dent based on correlations with biomarkers is a combination supplement with methyl B12, methylfolate, and low-dose B6. So I've reintroduced that, and I went into depth on Patreon in a Patreon post based on the correlations, why I made that re-entry into the approach. So if you're interested in that, check it out. I started that supplement on March 22nd. I'm planning on testing all of this again on April 22nd, March 27th to April 22nd. So I'll have about 3 to 4 weeks to see if it makes a potential dent on homocysteine. All right, on to page 2. So ApoA1 was 150 milligrams per deciliter, ApoB 68, and the ApoB to ApoA1 ratio was 0.45. Now, we can see that each of these are good based on the reference range, but what's optimal for each of these 3 biomarkers? So that's what we'll see here. On the y-axis, we've got the hazard ratio for having a major adverse cardiovascular event, or MACE. Now, MACE included a non-fatal myocardial infarction, so having a heart attack but not dying, stroke, and deaths from cardiovascular disease. And this study included 137,000 people with an 18-year follow-up. In other words, starting from the initial assessment of ApoB, ApoA1, and the ratio, who had a major adverse cardiovascular event 18 years later and who didn't. On the z-axis, we've got ApoB levels, and on the x-axis, we've got ApoA1. All right, so what's optimal? So for ApoB, we can see that less than 76 milligrams per deciliter. Note that the units are different on this chart. It says ApoB in grams per liter. So for ease, because on the lab report, it's in milligrams per deciliter, so I've converted it grams to liter into milligrams per deciliter for consistency with the lab report. So based on this plot, we can see that lowest risk for MACE is when ApoB is less than 76 milligrams per deciliter. Now, for this test, I was 68 milligrams per deciliter. Now, so that's good news. But note that one test isn't going to really, increase your risk. It's year-to-year change. So I obviously for this and all the other biomarkers, I'm tracking up to 8 times per year, maybe more this year, 8 times per year, and taking yearly averages and then tracking that over time, many years, with the goal of keeping as many biomarkers as youthful and healthy as possible to minimize risk, not just for having MACE, but all-cause mortality, and hopefully that can help extend my longevity. So we're all good with ApoB. Now, what about the reference range? So the reference range, as shown on the previous slide, was less than 90 milligrams per deciliter. So how does that look on this plot? So we can see that the data is still in the green, but you can see that risk has increased. And if ApoB continues to increase above that, now we can see that values that are 190 milligrams per deciliter are close to a 90% increased risk of having a major adverse cardiovascular event sometime up to 18 years later from the initial assessment. All right, so what about ApoA1? So based on this plot, we can see that greater than 150 milligrams per deciliter may be optimal, as the green boxes are completely flat, so lowest risk, lowest MACE risk, when ApoA1 is greater than 150. Now, for this test, I was exactly at 150, so all good there. What about the reference range, though? So based on the data on the last page, Quest Lab suggests greater than 115 milligrams per deciliter. And based on the plot here, we can see that that's definitely moving in the wrong direction. Now we're out of the greens and into an increased intermediate risk, as it's now in the yellow. So again, if we're focusing on the reference range, this may not be optimal. And there is data here, that would suggest a tighter optimal range. So what about the ratio, ApoB to ApoA1? Based on this plot, 0.2 to 0.6. And my ratio of 0.45 would be good based on this one test. Now, the lab test report, though, shows less than 0.77, which here, too, is now in the intermediate risk, increased intermediate risk, based on the ApoB to ApoA1 ratio. That's an error. I wrote that. I had it backwards, in the reference range, so apologies for that. But nonetheless, it would be an increased intermediate risk. So we can see now that what's optimal is different from the reference range. But then there's a different question that we can ask. Why are these data different? Why aren't the reference ranges up to date with the most current scientific information? And it's not even the most current scientific information. This data was published in 2021. But what I'd like to point out is the author, the first author of this study, so Waldius. And if I'm mispronouncing that, apologies, but Waldius, that's how I'm pronouncing it. And the reason I'm raising that is because if we look at, fortunately, the lab test report includes the data that they used to come up with their reference ranges. So for example, for ApoA1, they used this study here, which incidentally has the same first author. But what's different from their citation and the citation that I just used is they used a citation from 2004, whereas the data that I used was more recent, 2021. So that's just one part of the story, even though it's the same first author that wrote both studies. So after that 2004 study was published, at some point Quest used it to derive its ApoA1 reference range. Now, what's also interesting is note that the paper links the Amoris study. And the study that I referenced on the last slide is also the Amoris study. So in other words, they used early data from the Amoris study to inform their ApoA1 reference range. But 17 years later, 2004 to 2021, when the paper was published, there was more recent data. So I'd argue that the reference range, at least for Quest, should be updated with the more recent Amoris data that I just showed. All right, so moving past that story, back to the data. So glucose at 91, this is close to my average since 2015, so close to 60 tests of 90 milligrams per deciliter, so that's relatively good news. Also in the optimal range, 80 to 94. Creatinine at 0.76 is good news, as creatinine levels increase during aging. And I know that there are those who will say, well, creatinine is proportional to muscle mass. I don't think I lost a ton of muscle mass over the past 6 weeks since the last test. And when considering that creatinine levels increase during aging, it's better to have them on the lower side. And with that in mind, my 59 test creatinine average since 2015 is 0.94 milligrams per deciliter. So that it's on the lower side of my range is good news. But this is just one marker of kidney function. Let's take a look at others. So on to page 3. So first, highlighting cystatin C. And cystatin C may be a better biomarker relative to creatinine, as it's less sensitive to changes in muscle mass. So for this test, I was at 0.79 milligrams per liter, which isn't terribly high, but note that there is published data that less than 0.7 is associated with lowest risk of death for all causes. And again, that's on the Patreon tier if you want to see that data. So kidney function is relatively good, but I want to improve my cystatin C level. For another reason, it's included as a component of GrimAge, which is the best epigenetic clock for evaluating all-cause mortality risk. And I'll have that in a future video. All right, so on to liver function or liver health and function. AST and ALT values in the high teens, low 20s are optimal. Both of these data moved slightly in the wrong direction away from that relative to the last test. And with that in mind, I had GGT in, which was 12 for test number 1, which is good. And it's relatively youthful and associated with low all-cause mortality risk. So I took it out based on that. But knowing that my AST and ALT went up a bit from the last test, and I did change my diet, as we'll see in the next video in this series, I'm going to reintroduce GGT to see if that moved too in conjunction with the changes for AST and ALT. But there are other biomarkers that can be linked with liver health and function that suggests that liver health and function, in my case, is generally good. And one of those is albumin. We can see that it's relatively high at 5.4. And even though the lab flagged it, note that albumin levels decline during aging, and relatively higher levels, even in centenarians, is associated with a reduced all-cause mortality risk. Now, as a side note, some may say, well, if you're dehydrated, then your albumin levels can be high or higher than they should be. So if I was dehydrated before this test, we'd expect not just albumin to be high, but all of my biomarkers. I mean, glucose would be higher than my, almost 60 test average, or any of the other biomarkers on this sheet would be higher, and that's not what we see. Most of the data is within their usual ranges test to test. And to confirm that, I'll link the data to test number 1, and you can see that the majority of these biomarkers are similar to where they were for the first test in 2025. As one example of that, note alkaline phosphatase, which can also be linked with liver health and function, although it can also come from bone and intestine, is on the lower side, which it has been for many tests at 41. So collectively, these 4 biomarkers suggest good liver health and function in my case. All right, so next up is hemoglobin H1C. I wish that they would put it right below glucose in the lab report, but unfortunately they don't. So 5.3 isn't terribly high, but it increases during aging, and I've had lower values since 2015, but I've only measured it a handful of times. With that in mind, I'm going to include it for every test, as the goal is to keep it right at 5 to 5.1, which is where I've had it in the past, not 5.3 or 5.4 even, which I think is where it was for the first test in 2025. But then the weakest data of all my blood test data is my thyroid hormones. And for those who don't know, I was diagnosed with hypothyroidism in my 20s. So I've been taking levothyroxine for the majority of probably about half my life. So if you look at the free T4 and free T3, if you look at the ratio, between free T3 and free T4, mine is 0.18. Now, that ratio declines during aging. The conversion of FT4 into FT3 gets worse during aging, thereby leading to a lower ratio. FT3 is the active form of thyroid hormone, so we want that to be relatively high and FT4 to be relatively low. But in my case, that corresponding ratio is very low. To put that into context, the average value in 90-year-olds is better than my 0.18. So not only is this data worse than expected for chronological age, it's older than expected based on my chronological age. So with that in mind, I've been scurrying, trying to get doctors, an endocrinologist, and my PCP to change my thyroid prescription from T4, levothyroxine, which clearly I'm not converting well for whatever reason, whether that's aging or something else, I don't know. And fortunately, I was able to make some progress with that. So we recently modified my thyroid medication so that now I'm taking less T4 and I've added a small amount of T3 in, and we'll see how that impacts these thyroid biomarkers, FT4 and FT3, for the April 22nd test. All right, I'm also tracking IgG, as IgG levels increase during aging, and interventions that reduce it are associated with an increased lifespan, like calorie restriction, exercise training, and parabiosis. Now, what's optimal is very difficult to define, at least for me right now, because the aging data, there aren't epidemiological studies of millions of people that have looked at IgG, as this is not on a standard blood test report, and I have yet to come across all-cause mortality data for IgG in very large studies, not in studies of a few hundred people. So with that in mind, I'm planning on measuring IgG at every test going forward and collecting enough data where I can look at correlations for IgG versus other biomarkers. And then, in my case, is 1100, relatively higher, associated with more biomarkers going in the right direction versus wrong? Or should it be somewhere in 900 or 1,000? So stay tuned for that analysis, but it's going to take some time to collect enough IgG data. And then white blood cells, which the lab correctly flagged as low at 3.2. And it doesn't go into the data here, but we'll see that on the next page, why I agree with the lab's reference range as 3.2 being low. A high point is hemoglobin, or I shouldn't say high point, but good news is hemoglobin at 15.2. My 55 test average since 2015 is 15 grams per deciliter. Now, that's good news because hemoglobin levels decline during aging. And if you saw my video on cancer cachexia, that may be an important biomarker in the early stages of cancer cachexia where hemoglobin levels are low. So I don't know if that can be a diagnostic biomarker for avoiding cancer, but I'd like to keep my hemoglobin levels relatively high and avoid any age-related decline. Now, with that in mind, over 8 tests in 2024, that average for hemoglobin was 14.8. Now, you might think, 55 test average is 15 and then 14.8, not a big deal. You're worried about nothing. But isn't that how aging starts? It's 15. Next year it's 14.8. Maybe 2025 it'd be 14.6 average, 14.4. 10 years later, maybe now it's an average of 13.8, right? And if I hadn't been tracking it, maybe I would just be on that age-related decline for hemoglobin and all the adverse functional consequences that come with it, like an insufficient oxygen carrying capacity in blood. So with that in mind, that I've been able to get it back to 15.2, at least for this one test, suggests that it is continuing to be malleable, and I can keep it relatively high. Also good news is the MCV, so the mean corpuscular volume. This is the average red blood cell volume. How big are your red blood cells? MCV increases during aging, and over the past couple of tests, they've trended higher towards 93. So this is good news that I've been able to get them back closer to the lower end of my range, which is 91. All right, on to page 4 of the report, where we can see the RDW. This is the variability in red blood cell size. So do you have red blood cells that are mostly all the same size or a mix of small, medium, and large? If they're a mix of small, medium, and large, that's a higher RDW, which RDW increases during aging, and higher levels are associated with an increased all-cause mortality risk. The RDW is also the major predictor of Levine's biological age test. So in my case, we can see that 11.8 is relatively low and good news. So now for the white blood cell breakdown. So what's optimal for neutrophils is 2,000 to 3,000. Now, I'm below that, and that's potentially bad news because less than 2,000 is associated with an increased all-cause mortality risk. Now, if I'm going to be below or out of the range, the optimal range, for any of the white blood cell counts, I'd be okay with neutrophils being on the lower side of the range because they increase during aging. On the other hand, lymphocytes decline during aging, and this is actually now my lowest lymphocyte level reading since I started tracking in 2015, 55 tests. Now, lymphocytes decline during aging, so this is more bad news. Now, but also, is it that this is an age-related decline, or there's something that I'm doing in my diet that may be good for the majority of other biomarkers, but bad for lymphocytes? So without going into that story yet, note that lymphocytes, in agreement with the published data, in my case too, have declined during aging. So we've got lymphocyte levels on the y-axis plotted against chronological age, and we can see that significant inverse correlation as the correlation coefficient is negative 0.51, and we can see that the p-value is far below 0.05. So here, my data agrees with the published literature. Now, where the story gets interesting, and this brings back that HDL, that story that I mentioned earlier, is that lymphocytes are inversely correlated with my HDL. And usually the published data, well, granted, how lymphocytes changing during aging, in my case, agrees with the published data, at least for now, until I'm able to reverse this. But generally, my data doesn't agree with the published data. I'm usually an outlier. And there is published data that higher HDL is significantly associated with lower lymphocytes. And that's what we'll see here, too, in my data. So over those 55 tests, and again, note that we've got lymphocytes on the y-axis plotted against now HDL on the x, there is a significant inverse correlation in my data over those 55 tests for higher HDL with lower lymphocytes. So what does that mean? What does that translate into? What am I going to do with this information? Well, the optimal range for HDL is 50 to 60, at least for men. Again, the data is a bit wider ranged for women. When considering that my latest test was 67, which is outside of that range, I'm planning on reducing HDL to the mid to lower 50s. So getting my HDL data now within optimal. And if we go based on extrapolation of the trend line, I should expect to see lymphocyte levels that are closer to 1800. Now, it's not 2000, but I'd be working on optimizing two biomarkers, getting them closer to their optimal ranges, or one optimal and the other closer to optimal, whereas I've got one far from optimal lymphocytes and the other outside of optimal too. So what's the lowest shape of the U-shaped curve for minimizing risk for both biomarkers? That's the plan. So how will I do that? I'll have some of that story in the diet video that will come probably next week, but I've already detailed that story on Patreon, so if you're interested, check it out. All right, so two more biomarkers to go through. DHEA sulfate, which declines during aging, and note that DHEA sulfate is in the testosterone realm, right? So it's an androgen. My testosterone levels are generally high, 800 to 900, but my DHEA levels may have declined during aging. I had two values about 20 years ago that were 300, but I don't know if I was supplementing with DHEA, if that caused it or not. And if it was, I don't know what my normal levels for DHEA are, whether DHEA sulfate are, whether they're around 136 back then or not. Now, with that in mind, and knowing that DHEA sulfate declines during aging, over the past 3 years and over 20 tests, my average DHEA sulfate level is 126. So that I'm able to keep it on the higher end of my range, 136, for at least this test, is good news, as it helps me resist age-related decline. And last but not least is another weak spot, Candida IgG. For whatever reason, my immune system is having to work harder than it should to keep Candida IgG level or Candida levels somewhere in my body in check. And interestingly, I made a bunch of dietary changes prior to this test with the goal of reducing systemic Candida levels, but that clearly didn't make a difference, as 1.2, and I wish that was in grams per liter or some units. You know, these are in arbitrary units. They have no units. It's just 1.2. How do I translate into an actual value that I can compare with total IgG? I can't. If anybody has insight on how to do that for Candida IgG, please leave a comment. I'd be grateful for that information. So 1.2 is actually one of the highest values that I've had for Candida IgG. So I'm still working on things that I can include in my diet that can consistently keep that on the lower side or below the lab's reference range. All right, so what I haven't yet gotten into is what diet and supplements correspond to this 22-year younger biological age. And it takes me a few days to put these videos together, so the plan is to have it a week from today. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I include blood test consults trying to help others improve their blood test results. I also post at least twice a day in 4 other Patreon tiers. In terms of discount link and affiliates that you can use that help to support the channel while doing testing on yourself to see what may be optimal in terms of diet or supplements for biomarkers, I use ultralabtest.com, the clearly filtered water filter, at-home metabolomics, oral microbiome composition, NAD testing with Genfinity, epigenetic testing, at-home blood testing with Cyfox Health, which includes that DNA methylation test GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Diet Trying brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.